Hi guys, I'm Glenn Bigotayone. I'm student 24 and we're gonna talk about storm drainage system section 1101 to 1104. But this time we only focuses on example as the concept has been already discussed by student 23. So before we start, I just want to let you know guys that I mostly base my report on this book. It's called Plumbing Design and Estimate, second edition by Max B. Pardo Jr. So if you have this book, it's worth to check it out as it will help you understand more about plumbing. So without much further ado, let's begin our report. Size of storm drain. The size of storm drain is determined under the following consideration. So we have consideration for us to determine the size of storm drain. So we have 5. So the first is gauging the rainfall over a given period, whether it is constant or exceedingly heavy shower of short duration. So this is about the rainfall intensity and the time interval. Second is consider the varying roof areas, the slope, and the distance of water travel before it reaches the conductors of the roof. For us to understand this consideration, I prepared a table for this, but I'm gonna show it to you later. So, the third one is water drain faster in high pitch roof, hence that requires a larger drainage pipe than a flat roof. The high pitch roof it is 6 to 6.5 in height per 12 feet across. Fourth is the height of the building contributes largely to the velocity of water falling inside a vertical pipe conductor. The velocity to fall accelerate the flow of water entering into the storm drain. So, and lastly, the use of improper fittings in short offsets that will affect the flow of water must be avoided. So this is pretty much a heads up. So using improper fittings may definitely cause it may affect to the flow of water, and it may cause a problem later on. The conservative estimate of maximum rainfall in the Philippines is about 20 mm in a 5 minutes interval. Using this data, the approximate volume of water that will be accumulated on the roof in 1 minute can be readily computed using this table. So as you can see, we have a diameter of pipe from 75 to 350 mm in diameter, and we have in inches too, which is 3 inches to 14 inches in diameter. And we have maximum drain roof area, which is divided into 3 category, which is we have 2% slope, 3% slope, and 4% slope. These numbers you can see here are the roof area, but we have plenty of this type of data or table across the globe, since in different countries the rainfall is different, or the intensity of the rainfall is different. So the estimated rainfall there is different from us in the Philippines. So they use different data. Since we are here in Philippines, so we use this kind of data. So in order for us to understand this, or how to use this table or this data, I'm gonna show you an example. What size of storm drain is adequate to serve a roof having a slope of 2% with a general dimension of 20 by 30 meters? So how to solve this one? So first is we solve for the roof area, as the dimension has been already given, so it's easy for us to determine the roof area. So it's only 20 by 20 times 30, so we get 600 square meter. So we refer it right away in the table. Under the 2% slope, as you can see here, under the 2% slope is within the limit of 700 square meter roof area, so which is this one, so which is could be served effectively by a 150 millimeter pipe diameter. So our answer here is the 150 millimeter diameter. So we have to use the 150 millimeter diameter to be served. So if we use in inches, then we have 6 inches in diameter. So as you can see, it's easy, as we only need the roof area, then we refer it right away in the table, then we have the exact diameter of pipe that must be used or must be served. So next example, but what if we use the same dimension of the roof, or we have the same roof area but the slope is 4%? So what would be the storm drain size? So again, we solve for the roof area. It's the same, as we didn't change the dimension. So we have still 600 square meter, and they will refer it right away to the table. Then we have under the 4% slope, then we have 694 as this is the max. So if we reach 700, then we have to use which is belong here, the 1105, which is we might be use 150 millimeters, since the maximum is 694 and we have only 600 square meter. Then you have to use 125 millimeter for this one. So that's pretty much it. So it's easy, as we only need the roof area in order for us to determine the diameter of pipe that must be used or to be served. Roof leader. Roof leader is popularly known as water conductor or downspout, either concealed or exposed type. It connects the roof terminal to the storm drain. So we have two types of roof leader, which is the exposed one and the concealed one. So size of roof gutter and roof leader. So this table is pretty much the same on the storm drain, but this time we don't use those slopes anymore, as we only have the area of roof. We have 1 to 10, to 11 to 25, to 26 to 75, 76 to 165, and so on. And those types have a next to them is they have a designated diameter for gutter and roof leader, which is for example from 1 to 10, they have for the gutter top must be used is 75, and the roof leader that must be used is 38. So in order for us to understand this table or this data, I'm going to show you an example. So I believe this example is an activity which is to be passed next week, I guess, but I'm gonna show you how to solve it. So how large is a downspout required to drain the roof with a general dimension as shown in the figure? So as you can see, the roof, it has a dimension of 20 meters on this one, 10 meters, 20 meters, and 8 meters. In order for us to solve this, we have to isolate it. I'm gonna call this 10 by 20 as roof A, and gonna refer this 20 by 8 as roof B. In other words, let's say this right side of the roof, we're gonna refer it as roof A, and this 20 by 8 or the left side, or we're gonna refer it as roof B. So why do we have to isolate it? Here's why. Again, we have only to search the area or solve the roof area. Then the area of roof 10 by 20, 200 square meter, and you have to refer it right away in the table. So as you can see, we have 200 square meter. It belongs between 166 to 335, so and has a designated 100 millimeter diameter roof leader. Since the question only it only needs the downspout of the roof leader, so our answer is 100. So if the question includes the gutter top diameter, then definitely we have answer for it right away, which is the 150. But since the question only looking for the downspout, so our answer is 100 millimeter diameter. So that's only for roof A. But what about the roof B? So for roof B, again, we have to solve for the area, which is 8 by 20. Then we have the 160 square meter. Then we refer that away to the table. So it belongs to 76 to 165. Then our answer is 90 millimeter. Since the 76 to 165, it has a designated of 90 millimeter diameter. So our answer for the roof B is 90 millimeter diameter. So it's still easy, as we only need the roof area. So if you have the roof area, then we have to solve only for we will only refer it to our table. Then you will know the diameter that must be used or to be served. So more example, for 20 meters length of the gutter, the rain has to travel a long way. It might be overloaded and overflow. The terminal may be clogged with dirt such as leaves, etc. Thus, we need 2 or more terminals for roof leader. D equals to 100 millimeter and D equals to 90 millimeter. Is it expensive or oversized? So this time we have two diameters. In order for us to solve this, we use the 100 millimeter. So here's the solution. So find the number of terminals. Again, the question says, it is stated in the question, we need two or more terminals. So what if we only use two? So let's try only two. So yeah, we use 100 millimeter first. D equals 100 millimeter. Then we have to look for its cross section. So pi d squared over 4. I know you know how to solve this, as we have the diameter 100 and then we have the cross section, which is the 7,850 millimeters squared. Then we have to divide into two terminals. We get 3,925, and we choose D, our diameter, as 75 millimeter, and we solve for its cross section right away. Then we will get 4,416 millimeters squared, which is greater than 3,925. So why we choose 75 millimeter? So here's why. If we use 50 millimeter, the area we get is 1963, which is way below from 3,925, which is not good. It may overload or overflow. So if we use 90 millimeter, we get 6,359 millimeters squared, which is greater, way greater than 4,416, and it's not economic, as it may much more expensive. So using 775 millimeter is the right diameter must be choose. So that's only for diameter 100 millimeter. But what if the D equals to 90 millimeter? So again, it's pretty much the same process. We get the cross section of it. We get 6,359, and it divide it into 2. We get 3,179, and we choose again 75. Then we get the cross section of it. Then we get 4,416, which is greater than 3,170, which is good. So the D equals to 75 mm is okay. So here's the again the to prove, if we choose 50 millimeter, which is way below than 3,179, which is not good. It may overflow or overload the pipe. And D equals to 90, which is technically this can be used, but it's not economic. So let's proceed to our last example. It appears that roof A requires a 4-inch diameter and 3-inch diameter for roof B. If one roof leader will be installed in each roof, considering the 65 feet length of the gutter, the rainwater has to travel a long way before it reaches the roof terminal. Under such condition, the gutter might be overloaded and overflow is likely to occur. So this is pretty much the same on the previous example, but the difference this time is we use inches. So how to solve? The 4 inches diameter as found has a cross-sectional area of, so again we have to find the cross-sectional area. So we have the area, we get 12.56 square inch. I mean, divide it into two terminals. 12.56 divide 2, we get 6.28. And let's try D equals to 3 inches. Then we solve for its area, which is greater than 6.28. So using 3 inches, therefore specify 2 pieces of 3 inches diameter pipe. So if our answer here is way below, then the 3 inches is not suited for the problem, so we will have to use another diameter. But since 7.6 is greater than 6.28, so therefore we specify 2 pieces of 3 inches diameter. So I hope you guys learned something today, and that's pretty much conclude our report. So hope you guys learn, and thank you for watching.